We're going to talk, Sean, about Freefall, but first, I can't remember which block it was, but the other day when we talked about G's, who remembers how many G's was usually fatal? I didn't make you memorize it, but just nerd trivia. Around 25-ish. When did you usually start to break a bone? Around 10. Usually you pass out around 7 or 8, but somebody in some block said, hey, Mr. Duke, what's the biggest number of G's ever survived? This is the one that we have video evidence for, because it happened during a race, and there were cameras rolling, and so we could run the numbers. Someone may have survived more than this in a car accident because it wasn't captured on film. I have no idea. And when I say survived, David Purley had permanent damage. But here it is. In 1977, in Northamptonshire, England, David Purley's race car crashed, and his speed dropped from 174 kilometers per... No. I'm going to lightly cross out the 174 just to make sure I don't accidentally use it. What am I going to do with that? So what do you get? I'm going to store that on my calculator. I think it's actually 48.3 repeating, right? I'm going to write really lightly above here 48.3 meters per second, and I'll store that on my calculator. Of course, my phones are put away or face down, so they're not a distraction at all, right? My phones are put away or face down, so they're not a distraction at all. Thank you. 174 kilometers per hour. Is that fast? Okay, he came to a stop in 0.66 meters. So basically, he went from 174 to 0 in about that. Well, a meter is about like that. So 0.66, about like that. It's a pretty intense acceleration. All right. He had 29 fractures. He had 3 dislocations. His heart stopped 6 times, and he did not fully recover. He had permanent pain and injury for the rest of his life, but he did survive. Jazz, what's this question wanted me to find? What's this question really asking me to find first? I have to find acceleration first, and then I'll convert it to G's. So let's write down A equals question mark. Jazz, what's that 48.3? Yep. Oh, what's VF then, Jazz? We said in any car accident ever, we can assume that VF is 0. What's that 0.66? It's technically good. It's technically a displacement, but yeah, 0.66. Is the 29 a physics concept? No. Is the 3? No. Is the 6? No. So I glanced at those and I said, you know what? No units next to those. Ignore them. Jazz, which equation has an A, a VI, a VF, and a D in it? Can you get the A by itself, please? You are correct. That is the right equation. How would you get the A by itself? Yep. What side is the A on? So what's going to drop down like a domino? There isn't a VF. I got to be fussy. It's a VF what? Okay, let's be meticulous. Keep going. Is the VI squared being subtracted on the right-hand side? Okay, so how will I move it over then? Not plus it, but okay, sloppy mistake. We won't do that. Yeah. Now, if you're comfortable going straight to the equation, that's my goal. If you're still having trouble rewriting and finding the correct equation, now is the time to stress, not panic, but stress. In other words, now you want to be tracking me down during a flex or after school. Tomorrow is a late start day, so no flex block. Tuesday flex, or if you want to, on Mondays and Tuesdays, I'm usually here till 4:30 in the robotics room, which is next door to the metal shop. I'm just sitting there watching kids play with robots, and I know last year I had a couple of students that came by every time, and I could give them a good one-on-one tutorial, or they just worked on the homework from that day, and then they went home, and I'm fine with that, but let me know ahead of time, because sometimes I won't be there because I have a different meeting, Amber, that I have to be at, but usually I'm there, or flex. Let's crunch the numbers. It's going to be 0 squared minus, I'm going to write 48.3, but you know I'm going to use my answer button, divided by 2 times 0.66. So I got to get that 48.3 on my calculator. So first it was 174 divided by 3.6. There we go. Bracket 0 squared minus answer button squared, close bracket, divided by 2 times 0.66. Oh, when he hit the wall, did he speed up or slow down? Be obvious. Am I expecting a positive acceleration or a negative acceleration? So the negative doesn't creep me out. That's a pretty big acceleration. Negative 1,700. You know what? I'll give him the benefit. We'll round up. He's earned it. Negative 1,770. Units, Jazz? It's an acceleration. Good. Now, that's not what the question really asked, though, Peter. What did this question really ask? How many what? How do I convert this to G's, folks? Divide by 9.8. So, G's is going to be, I'm going to write negative 1,770, but you know I'm going to use my answer button again. And it's at negative 180.6. Negative 181. Jeez. Yep. Okay. I did some research, did some Google searching, and that's the biggest I've been able to find where we had the numbers to verify it. Again, in a modern car accident that wasn't on video, maybe someone has survived more, but we just didn't have the data. That's what I got. Oh, you've seen, I think it's the new iPhone 14s. They have a G meter inside that will automatically detect if you're in a car accident and notify the authorities. So it must detect beyond a certain G threshold, maybe 15 or so, time to call an ambulance. It would be interesting. Could you wear that and play football, or would it think every time you were getting tackled or getting body checked in hockey? Yeah. Well, that would be interesting questions to find out. I haven't got the most recent iPhone. I'm going to guess if they were smart, maybe they also have it only work if it's paired with your car's Bluetooth or something like that. That's the only time it's activated. But then you could say, what if I throw it right next to my car while it's still paired? And you probably wouldn't want to because it might make an emergency call, and then you're on the hook for I phoned an ambulance when I shouldn't have. And I think it's a couple $100 fee, and you can get in trouble. So there's my answer off the top of my head. But it'd be interesting to try the experiment with maybe in airplane mode or something so it wouldn't make the phone call. Let's talk about freefall. When an object is falling through the air, we say that it is in freefall. In freefall, because the only force acting on you is gravity, we know the acceleration. What was the acceleration due to gravity? As a number exactly. How big was 1g? 9.8. But now we're going to be meticulous and fussier with our directions. In free fall, we're going to let down be negative and up be positive. So gravity, does it make you accelerate up or accelerate down? So what are we going to say for the acceleration due to gravity then, Matt? It's not 9.8. It's technically louder so my YouTube people can hear you. See, YouTube, I have some students that can figure this out. Negative 9.8 meters per second squared. By the way, an object is in free fall if the only force acting on it is gravity. So when I throw this tennis ball, it's in free fall on the way up. On the way up, is it speeding up or slowing down? So its acceleration should be what? Negative 9 point. Yeah, that makes sense. It's slowing down. That works in our convention of slowing down as a negative acceleration as well. But then on the way down, it's speeding up. Now the negative is, it's speeding up in the downwards vector direction. So we're going to let down be negative and up be positive. Why did I write near the Earth? Not just the moon would be different. What happens to Earth's gravity as you get further from it? Okay, it changes. It weakens. We'll talk about that more in Physics 12. In Physics 12, I'll show you Newton's law of universal gravitation, which lets you find the force of gravity from any planet anywhere in the universe. We don't have that, so we're going to assume that gravity is constant. Well, we're going to assume, Amber, that we're not going thousands of miles from the Earth. We're sticking nearby, near the Earth. And you're right, it also changes on other planets or celestial bodies like the Moon or like Mars. Free fall is cool. We kind of like it. If we can safely jump from things, it's kind of scary, and so some people can't overcome their fear, but those that can find it's kind of addictive. Put your pencil down, look up. So there's something called base jumping. Where is it, Mr. Duick? This is in Norway. Base jumping is when you jump not from an airplane, but from a object, building, or cliff. Is air resistance playing a role here? Yes. If in a vacuum, that parachute would be dropping just like a rock. So we're going to ignore air resistance, but we do need to point out that that means our physics is going to be inaccurate sometimes. This next one is interesting. How many of you have ever done the activity called a trust fall, where you're supposed to fall backwards and your friends will catch you? That's one that people find very tough to do. This person is going to trust fall backwards over the cliff. I don't know if I could bring myself up to do that. Right here. I don't know if I could, without looking, fall backwards off of a cliff quite that casual. I really have to psych myself up. You can also see it looks like they're flying with the cameraman. They're using air resistance to swim through the air. It's the same physics motions as when you're swimming. It's just not as effective because air is a less dense fluid, but it's going to be the same kind of motions as well. So this is the same guy that fell backwards off the cliff. Clearly he's done this a lot because he also was able to turn over on his back, and I don't know if I could fall backwards to the ground either. I think even if I was skydiving, and I have skydived, I'd kind of like to see what I'm heading towards. So these people, they know what they're doing, but they are experiencing free fall. And in the absence of air resistance, they would all be accelerating at negative 9.8 meters per second squared. So let's analyze some of this stuff. Example 2. A cannonball is dropped from a cliff. All of you right now, could you please underline the word dropped? That's going to be in the same way at rest or came to a stop is a trigger word. Adam, the word dropped is a trigger word. If we drop something, what can we assume VI is? Okay. It hits the ground 10 seconds later. Noah, what's A asking me to find? In terms of our 5 physics concepts, and I'm going to be fussy, we're going to find a displacement. I'm going to give you a little spoiler. Is the cannonball ending up above or below from where it starts? Where does it end up? We're going to get a negative answer. We're going to get a displacement. Just tell it, the universe is telling us, oh, by the way, I'm pretty sure you ended up below from where you started. So I'm going to be a little fussier with my vector notation. I'm going to put the vector sign on the D just to remind myself I am going to get a negative here. What else do I know? Well, VI is 0 because it's dropped. Noah, what's that 10.6? How'd you figure that out? Yeah, look at the units. This morning I had somebody say, no, time! They were like, yeah, check the units out, right? Problem, that's 2 things. I need 3 things to find the 4th. Anytime we're in free fall, Noah, what else do we know? More specific as a number exactly. You wrote it down about 30 seconds. Thank you. Negative 9.8. No, I'm looking for an equation that has a D, a VI, a T, and an A in it. There is one. Noah's right, but he wasted my time. Noah, what's VI? What's VI as a number exactly, Noah? I would have smiled if you had said D equals a half AT squared and skipped the VI. You don't have to, but I'm going to start to try to train you. Hey, keep an eye out for zeros and ones and things. And you'll notice I'm so lazy I didn't write the full 1/2. I wrote the half part because the 1 isn't going to change anything when we times by 1. What are we trying to get by itself, Noah? Bonus it already is. So plug and chug. It's going to be negative 9.8 times 10.6 squared all over 2. 10.6 seconds of free fall is a lot. This is going to be a pretty high cliff. This would be a cliff that all of you would feel uncomfortable standing at and looking over the edge. You would feel woozy and you would probably want something to grab onto. Some of you might even get so dizzy that you would lose your balance. What'd you get, Noah? In fact, I'm pretty sure it's going to be in the negative 500s, I think. Is it not? Give it to me to 3 sig figs. Give it to me to 3 sig figs. So you're going to give me a total of 3 digits. Negative 51. Did that round it off properly? Units. Noah, my friend. Meters. Okay? Now, we found a displacement. Do you ever in English say, hey, that cliff is negative 551 meters high? Does that make sense? No. Typically, height, Noah, is a scalar. I would take this. You might see in the answer key, it might be given as a positive answer because just when we're talking about heights, we usually measure from the ground up. But here, since we were starting at the top of the cliff and we were finding a displacement, we ended up with the negative. I'd take either in your answer, but when you're comparing your answer to my answer key, you might, why is it positive? Because it used the word height, not displacement. Is that all right? Cool. Jazz and Deep, what's B asking me to find? Good. A common mistake, kids say, Mr. Dewick, isn't VF 0? No. If VF when you hit the ground was 0, I could ask you to stand on your table and do a belly flop onto the cement floor and it wouldn't hurt. Will it hurt if you stood on your lab table and did a belly flop onto the cement floor? Yeah. But if VF was 0, it wouldn't. VF is 0 after you hit the ground, but not when you hit the ground. So that's one of my big pet peeves, and I will lovingly freak out if we're doing a projectile free fall question and you tell me when we hit the ground, isn't VF 0? No. Jazz and Deep, has anything else changed, or is it still 10.6 seconds and all that stuff? Then I'm not going to relist the data. I've got it right here. If something had changed, I would relist stuff. I'm looking for an equation that's got a VF, a VI, a T, and an A in it. There is one. I'm not going to use D because if I got D wrong, I'm getting B wrong as well. Which one? Yeah, first one. What is it? Oh, you wasted my time again. If you were clever, you could have just said it's AT because VI is 0, and that would have made my little math nerd heart go pitter-pat. But no, fine. Jazz, when we hit the ground, what direction are we traveling? Am I expecting a negative or a positive velocity here? Negative 9.8 times 10.6. It's going to be around negative 100, but not quite. Negative 104. Round it off to 3 sig figs properly. Is that fast, Mr. Dewick? That would definitely be fatal for a human. Well, yeah, if a human being fell off a cliff that was 550 meters high, half a kilometer high, they're not surviving. Sorry, I got to be careful. They're almost certainly not surviving, but we have had people survive longer free falls than that through various strange and extenuating circumstances. We'll dive into that another time. You know what? I need to prepare a handout on the longest survived free falls. I never have, and I really should because that's also kind of interesting. C. Okay. What's C asking me to find? Amber, what's C asking me to find? Good. Thank you. I was worried I was going to have to ask you which velocity? Final velocity. How do you know it's the final velocity and not the initial velocity? Because what's VI if we dropped it? Good. So let's write down VF equals question mark. Has the time changed? Say yes. So let's relist what we can. We still know VI is 0. Is A still negative 9.8? Yep. T is 3.6. Amber, which equation? I knew I could count on you. You saw me crossing my fingers. Will she remember? Will she remember? Good. VF equals AT. Yeah, it's the same question we just did, isn't it, with different numbers. Negative 9.8 times 3.6. We haven't fallen for as long, so the magnitude should be smaller because you do speed up as you keep falling. So I'm guessing it's going to be a smaller magnitude than 104, I hope. So there's some built-in error checks. You can be alert looking at your calculator where you can spot if you've done a typo because you get a nonsense answer, right? Amber, what'd you get? Negative. High 30s, low 40s, I think. Here's what I heard. Negative 35. Point what? Is that rounded off properly? 0.3 or 0.4? Okay, yep. Negative 35.3 meters per second. Good. D is the same question that we started with jazz. I think it was with jazz displacement. How far? I'm going to skip it. It's just, it would be this same thing, but instead of 10.6, put a 3.6 in. We got that. You would again get a negative answer though because it's below from where you started. I want to move to the next situation. The next situation, we're going to throw a ball on the way up. Ball is thrown straight up with a velocity of 29 meters per second. Now, I had somebody very clever last class ask a question. They made a good point. Let's decide that when we're launching a ball straight up, it's launching from the ground, not from a person's hand, because otherwise we'd have to take into account the height that the person's hand was off the ground. So to make life easy, you can either assume the person's laying on their belly and throwing it up, or, you know what, we've got a cannon that's just barely sticking out of the ground, and that's launching it. Okay? Okay. Carter, what's A asking me to find?
It's asking me how long.
Yeah, which physics concept is it asking me? Yeah. I'll give you a hint. It's not asking me to find VF. Good. This is you'll notice I keep using how long because I've told you in English, how long is vague. How long can mean distance or time. And how long does it take? Oh, that's time. What's that 29?
29.
I agree. It's what we started at. And then, are we in free fall? We are, even on the way up. What's the acceleration?
So that would be...
Nope. Because on the way up, it's slowing down. Negative. And on the way down, it's speeding up downwards. Negative. It's always negative 9.8. Again, as long as we're ignoring air resistance. Problem. That's two things. I need three things to find the fourth. There's something else that I know. Derek did that. I thought he was going to sheep. What's VF?
0.
Okay, at the top. Look. At the top, for a split second, it does come to a stop. This is where VF is 0, not at the bottom of a cliff, but at the top of a toss. Which equation? By the way, that you'll have to kind of commit to memory, although it looked like most of you kind of spotted that intuitively.
That would be...
Can you get the T by itself, please? I agree. So it's going to be 0 minus 29 divided by negative 9.8. Now remember, time is a scalar. It's the scalar in this unit. It's always, by default, going to be positive. If you ever get a negative time, you've messed up somewhere. Don't just ignore the negative. Go figure out where you messed up. It's going to be a little less than 3, but I can't do much more than that because it's almost 30 divided by 10, but it's a little less than 30 divided by 10. 2.96? Yeah. Seconds. You've all just turned the page. Yes? Are you going to? When you turn the page, can you write down again for your list VI equals 29, A equals negative 9.8? So VI equals 29. A equals negative 9.8. Taya, what's B want me to find? We're going to, are we above or below from where we started this time? We better get a positive answer. If I get a negative answer, I've messed up. So I'm going to go D equals question mark. At the maximum height at the top for a split second, Taya, how fast are we traveling? We can still use the V final is 0 trick. Looking for an equation that's got a D, a VI, an A, and a VF in it. There is one. And the brackets will show up on your calculator. I usually don't bother writing them because they're implied, but I totally agree with that. It's going to be 0 squared minus 29 squared all over 2 times negative 9.8. I've got a bit of an advantage because I know 29 meters per second is not that fast. That's about what a mediocre high school pitcher can pitch at. So most of you can't throw that fast, but somebody who's done a fair bit of pitching in high school could. A major league pitcher can pitch around 45 meters per second, not 30 meters per second. So if you imagine a high school kid throwing a ball in the air, I don't think you're getting 300 meters or anything like that. In fact, I'm pretty sure it's going to be less than 100. I'm pretty sure. What do you get, Taya? 42 point... Units? Meters. Okay. That seems ballpark right to me. C. What's the impact velocity of the ball just before it hits the ground? Not 0. Callie, what's the impact velocity of the ball just before it hits the ground? Too slow. Cameron, what's the impact velocity just before it hits the ground? Too slow. What's the impact? No, don't need to write anything. When I say too slow, what I'm really saying is you know the answer already if you're clever. All of you should know the impact velocity when it hits the ground. Yeah? What?
Negative 104 meters.
Nope. Yep. Negative 9.8 is an acceleration. I'm going to say that's a bad guess for a velocity. You okay with the way I said that? Like I would say to you, wait a minute, don't be telling me meters per second squared can be used as a guess for meters. We see it. Jazz? No, it's a stretch. There's a saying that says, what goes up must come. What's the final velocity?
29 meters.
Can't possibly be 29 meters per second. Which, by the way, technically isn't true because things in orbit don't come down, but to help you remember this as a hook, I'll stick that in there. Now, that only works, Amber, if we're starting and ending at the same height on the ground. But yeah, whatever velocity you left with, that's the same magnitude that you'll hit the ground with, but in the opposite direction, so negative. Okay. D. How long is the ball in the air for? How can I find that? Well, there's two ways. If I look at my answer from A, how could that help me figure out the total time of flight? Yep. Because we're starting and ending on the ground, not on a cliff, we could just take our answer from A and double it. And for this question, that's what I would do because I'm lazy. So, but there's a second way. Because there's a second way, I'm going to draw a little line down the middle, and I'm going to say this. One way would be time to the top times 2, which in our case is going to be 2.96 times 2, which is what? 5.92 seconds? The second way, now a lot of kids just glom onto this, and if this is how you're comfortable finding time of flight, oh, I'll let V final be 0, I'll find time like we did in part A, and then I'll just go times 2 my answer. I'm fine with that. But me, I'm lazy but organized. I wouldn't want to find something in order to find something if I can go straight to the punchline. I wouldn't want to find two things. So the second way would be to go T equals question mark. VI is positive 29. VF is negative 29. A is still negative 9.8. And you can use T equals VF minus VI over A. And I think if you type that into your calculator, you'll also get 5.92 seconds. Jazz, either of those, I'm totally fine with. Okay. Do you get 5.92? Double check me. So it'll be 29. Sorry, it'll be negative 29. Take away 29 divided by negative 9.8. You should also get 5.92. And in fact, this one would be more accurate because the 2.96 was a rounded off value. So we used a rounded off value times 2. I probably, if I had time, would do it this way. Is that all right? It's 5.92. Thank you. What's the displacement of the ball once it hits the ground? Because how high was it when it started? 0. How high was it when it finished? 0. What's its displacement? So, we dropped something from a cliff in example 2. In example 3, we threw something from the ground. In example 4, we'll combine them. We'll throw something from a cliff. You can either throw it straight up, in which case VI will be positive, or you could stand on the cliff and throw it straight down. How would I show straight down? VI would be easy peasy. We can do that. But we are going to pause here. I'm going to give you some time to work on the take-home quiz. But first, I have also experienced freefall.